All right, guys, this is the second and final notes / homework that you're going to have to do over break. I don't think these will take you too long. Remember, all you have to do is watch this notes video, take notes along with it, and then do the homework assignment that's on the back of this page. So you'll have to scan and submit those for each of them. Before I do this one, I know that in the negative exponent video, we kind of proved why the negative exponent works. Before I even do this one, I'm just going to explain the rule so that we can just start using it. So if I have something like x to the a over b, so I've got an exponent that's a fraction, that's equivalent to the b root of x to the a. So before we start losing our minds here, I know we haven't dealt with too much anyway, with having numbers here in the argument that are not a 2. So we'll get to a point today where we talk about that. But that's what this would be. So this is kind of like our rule that you would absolutely have to remember and utilize for the rest of the notes here. So let's apply that to letter A. So letter A says I have 16 to the 1/2 power. Well, according to my rule, that says that that's going to be the same as the square root of 16 to the 1st. And we know that 16 to the 1st is really just 16, and square roots are implied when you draw that radical. So you don't have to write the 2 there. If it were any other number, then you would have to write it. So really what I'm asking here by saying 16 to the 1/2 power is what is the square root of 16? And that is 4. So there's your introduction to rational exponents. Now let's start using them in a little bit more complex way. B says 8x cubed to the 1/3 power. So what is this asking? Well, it's saying we're taking the cubed root of 8x cubed all to the 1st power, which we know would just be 8x cubed. And now we can try to simplify it from here. All right, so the cubed root of 8x cubed is the same as the cubed root of 8 times the cubed root of x cubed. Okay, now let me explain here. That the cubed root of 8 is 2, and that's because 8 is really 2 times 2 times 2. Right? That's the prime factorization of 8. So if I've got 3 2's that multiply together to make up 8, then the cubed root of 8 would be 2, because it's 2 that if you multiplied it by itself 3 times would give you 2. So essentially, if you've got 3 of these guys under here and you're taking the cubed root, then 1 comes out, and you end up with a 2. The same thing is happening here with this x cubed. So we have the cubed root of x times x times x. Well, what is it that if you multiply it by itself 3 times gives you x cubed? It's x. So the cubed root of x cubed is x. So the answer here then is 2x. And remember that if you picked up on it, you can make life a little easier for yourself here. One thing you could have done is you could have said that 8x cubed to the 1/3 power is the same as 8 to the 1/3 power times x to the, and remember, when you raise a power to a power, you multiply. So x to the 3/3 or 1st power. And then you could take the cubed root of 8 and get 2. So remember that multiplication rule. Let's make a little note to ourselves over here about how we dealt with that radical. So if I have a radical, and I have some number here in the argument, I don't know what it is, but whatever's in here, if it's the same thing multiplied by itself, a times, then the answer is that thing. So for example, let's say that we had something like the 4th root of 3 times 3 times 3 times 3. There are 4 of them here, right? There's 4 of these. So the 4th root of 3 to the 4th power is 3. And 3 to the 4th power is 81. So the 4th root of 81 is 3. And we're probably going to use that in the near future as well. So keeping that multiplication rule, our power rule in mind, what we've got here with C is we've got 25 to the 1/2 power times x to the, we multiply our exponents, 2/2 power, times y to the 4/2 power, times z to the 1/2 power. So some of these things will simplify here and make life easy for us. We've got the square root of 25. Can't do anything about that just yet. We've got x to the first. We've got y to the second. We've got the square root of z. The square root of 25 is 5. So I have 5xy squared and then radical z. And there's nothing I can do about that radical z. There would be if I had 2 z's under there, but there's only 1. So there's nothing you can do to simplify that. So that's what that would look like simplified. And then this last example here, D, says that I have 4x to the negative 3/2 power. So hopefully you watched the negative exponent notes before these. But when you have something to the negative power, that's the same as 1 over that whole thing to the positive exponent. Okay, so what we have here is 1 over, we've got 4 to the 3/2 times x to the 3/2. Now the question would be, can we simplify any of this? So let me do some work on this over here. I've got 1 over. 4 to the 3/2 means the square root of 4 cubed. And where that's coming from is over here. Our rule, what does it mean when you raise something to a rational power? The denominator becomes the argument, and the numerator becomes the exponent of that number. So I've got the square root of 4 cubed times the square root of x cubed. So let's try to simplify this a little bit. We could think about it in terms of numbers with this 4. 4 to the 3rd power is 64, right? Because 4 times 4 would be 16, and 16 times 4 is 64. So what we really have here is the square root of 64. And over here, I'm just going to demonstrate for you what this would look like if we just expanded it. We've got x cubed, which is the same as x times x times x. All right, so the square root of 64 is 8. But what do we do about this square root of x to the 3rd? Well, we said that if this was just 2 x's, then I'd be able to bundle those 2 x's, and the answer would be just x, because the square root of x squared would be x. But we have 3 x's here, so I can't take 2 without leaving anything behind. I'm going to take these 2 x's out of here, but notice I'm still going to leave an x behind. So an x will come out of the radical, but I'll still have an x left inside of the radical. So my answer is 1 over 8x radical x. And there's nothing more that I can do about that. So if I were you, there are probably a lot of things that happen there. I might make some notes of things that you have questions about, or something you need more practice with, or something you noticed that maybe is new. You could make a note of that over here on the left in the notes and questions section. And hopefully that's enough to get you through the practice and homework problems on the back of this. Remember, do the homework or the practice problems on the back of the negative exponents worksheet, and do the same for the back of this worksheet. Scan and submit them. All right, guys, have a good break, and I will see you all on Monday.